want to obtain a sample to estimate a population proportion. Based on previous evidence, you believe that the population proportion is approximately 0.74. You would like to be 98% confident that your estimate is within 0.02 of the true population. How large of a sample is required? When we are dealing with population proportions, there are two possible formulas for sample sizes, and I've written them here. We have the sample size should be P times Q times Z critical squared divided by the error squared, or the other formula you might use is the sample size is equal to a quarter times Z critical squared divided by the error squared. Now, you decide which of these two formulas you use based on the information that's given in the problem. If you know what your value of P is, then what you're going to do is you are going to use this first formula. If you do not know what the value of P is, then you have to use this second formula here. Now, in the problem, it does give you an estimate for the population proportion. So we are going to use this first formula. If that information wasn't given, then we use the second formula. So using this first formula, I know what my P is. It's 0.74. And even though it doesn't give us the value of Q, I know what Q is by finding the complement of P. And that would be, I would take 0.74 times 0.26, because when I add up 0.26 and 0.74, that's going to give me 1. Q and P should always add up to 1. Now, for my Z critical, I have to do a little work to figure that out, and we'll put that in here. So whatever we get when we find Z critical, that will go here and we'll square it. And then our error squared, it's given to us in the problem that our error is 0.02. So that's going to go down here, 0.02, and I'm going to square it. Now, to find our Z critical, we use our confidence level, and this problem told us that we're 98% confident. So in the center, we want 98% of the data to fall in this interval. So we're trying to find the cutoff points each side here to give us our Z critical. We're trying to find how many standard deviations out from the mean we are from here to here. So that means if I want 98% to be in the center, then what's left over from 100 would be 2%, and we have to split that up on each of these wings. So each of these wings contains 1%. So I'm going to use inverse norm on the calculator, and I'm going to put in 0.01. And I'm going to get that this cutoff point right here would be negative 2.33 when we round to two places as the direction states. And this would be positive 2.33. Now we always, for critical values, use the positive because we're only looking at the distance, not the direction. So I'm going to put in here 2.33 for my Z critical. When I put all of this in on my calculator, I'm going to get 2611.3. Now recall that when we're finding sample sizes, we always round up to the next whole number, always round up. And that way our sample size is always big enough. So my final answer, what I'm going to put into the answer box, is 2612. That is going to be my final answer for my sample size.